pOH, H plus and OH minus concentrations, calculations. Now, what I'm going to tell you is that these calculations look scary. A lot of students have the tendency to immediately look at it and think, oh my goodness, this is difficult, I can't do it, I'm confused. I'm going to tell you, all the formulas are in your reference table, and they've taken the scary stuff out. So you see that we do have logs, but it's not hard because your reference tables have done the algebra for you. All of the formulas are there. You just need to figure out exactly how to put it in your calculator. I'll walk you through how to put it in a graphing calculator. If you have a scientific calculator, you need to make sure that you talk to your sub, that you talk to a neighbor, you get figured out how to put the logs in there. Because that's really all you need to be able to know how to do, is how to do this in your calculator, pick the right formula, and you got this. You got this. These are not that tricky. Do keep in mind, and here I'll show you the formulas. Here they are, all right here. pH equals the negative log of the H3O plus concentration. You remember that the brackets mean concentration of. So I'm going to point out some of the problems that I've already given you. If you look, OH minus equals, OH minus in brackets, equals 2.64 times 10 to the negative 13 molar. We always have a unit when we've got this. So I'll show you that today as we're working it out. But this means the molar concentration, or the molarity. So therefore it does need a unit. So we've got this formula here. To find the pH of something, the definition of pH is the negative log of the H3O plus concentration. Now, your reference tables on the formula page actually show H plus instead. This is the hydronium ion. It's H plus combined with water. But you remember that in this class we can kind of consider them to be the same. A lot of scientists use them interchangeably. So I'm using this here. Your reference tables has H plus. You need to recognize them as basically the same. Okay? Okay, so the hardest thing here is just, honestly, just figuring out the correct formula to use. But even that is not that hard. So don't get scared by all the numbers, all the weird logs, all the exponents. It really is not that bad. Okay, here we go. So problem number 1, find the pH. So we're looking for one that we need the pH. We are given the H3O plus concentration. It's right here. So let's find a formula that has pH in the answer using the H3O plus. Oh, look, right here. pH equals negative log of the H3O plus concentration. That's our formula. So what we need to do is just plug it in. pH will equal the negative log of this number, 1.00 times 10 to the negative third. And some of you who are great at math won't have to put that in your calculators. You guys will know the answer is going to be 3. But here's how we do it. The negative is in the bottom right corner. The log is right to the left of the 7. So the left of the 7 is where the log is. And type this in. 1 times 10 to the negative third. And I just got 3. Now, honors folks, you do need to watch sig figs. However many significant figures are in your first answer, that's how many should be in your final. Academic, doesn't matter how many digits you write. Okay? So 3.00, and there you go. Let's think about what this number means, because I'm constantly going to be asking you, is it basic, acidic, neutral? Remember, any pH below 7 is going to be acidic. This pH is below 7, so this is actually an acid. Let's do this one. pH equals the negative log of 6.59 times 10 to the negative 10. Oh, one thing I meant to say earlier, as I'm putting this in my calculator. By the way, even though you're just watching me do this, I still want you to be putting this in your calculators. So please, right now, if your calculators are not out, pull them out. Pull out your calculators, and please work this through with me. Negative log, I'll talk about units after we get this answer. 6.59 times 10 to the negative 10. And I got 9.18. So there's my answer for that. Notice pH is unitless. If we're calculating the brackets, that's molar concentration, it's molarity. We have to have the capital M at the end. If we're calculating pH, it's unitless. No units. So there we go. Let's look at this number. You see how it's above 7? The pH is above 7. That means that this solution is actually a base. Okay, let's move on to the next one. Find the H3O plus concentration, or H plus concentration, given pH. So let's find a formula that has this as the answer using this. Oh, right there. H3O plus concentration equals 10 to the negative pH. So that's all we have to do. H3O plus concentration equals 10 to the negative pH. Now, unfortunately, you can't write this as your answer. We're going to put it in this form right here. So we're going to say 1.00 times 10 to the negative third, and we need a unit. It's molarity, so we need a capital M. There you have it. Now let's think about this. I ask my students to go back and look at pH. Anytime you're trying to figure out if something's an acid, base, neutral, look at the pH. Our pH is 3. This is definitely an acid. Okay, let's plug in this one. Because we're still trying to find H3O plus, we're using this formula right here. 10 to the negative 6.61. You cannot write 1 times 10 to the negative 6.61. You can't put a decimal place up here as your exponent. So this one you definitely have to plug into your calculator. 10, use the caret, that's right above the divide button. And negative 6.61 equals, I want everyone to put that in. So go ahead and pull out your calculators, type that in yourself. I got 2.45 times 10 to the negative 7, capital M. And there you go. Okay, pH tells us it's 6.61, so is that an acid, base, neutral? It is an acid because it's below 7. Technically, the only thing that's actually neutral is 7.0000. Technically, 6.9 is an acid, 7.0 is neutral, 7.01, that's a base. So that's going to help you know what to put there. There we go, needs a unit. I do want to say my honors folks, let's talk about sig figs here. I did only have one sig fig here, so it would be best if you did not include those extra zeros. Since we only have one significant figure here, we should only have one in our final answer. And since this one has 3, our final answer should have 3. So do make sure you're still watching the significant figures. Okay, let's look at the next type of problems. Find the pH if the pOH is 1.26. Okay, we got to find a formula that has pH and pOH there. So let's come over here. Oh, right here. These are actually the easiest of all the problems. pH plus pOH will always equal 14. Yay! pH plus pOH will equal 14. If you remember, the pH scale only goes up to 14. So it doesn't make sense. That's kind of why this number is really pretty significant. And you can see it here too with our KW formula as well. So they should add up to 14. So the pH is going to equal 14 minus 1.26, because the two should add up together to equal 14. So 14 minus 1.26, and we get 12.47. And that is our pH. Notice, honors folks, this one went to the hundreds, our final answer goes to the hundreds. Academic folks, doesn't matter as much for you guys how many digits you write down. Okay, let's think about what this number means. I would suggest you look at the pH to figure out if it's an acid, base, or neutral, because that's the scale we know better. 0 to 7 is an acid. 7 exactly is neutral. Above 7 is going to be a base, so this one's a base. And let's do this one. pH equals 14 minus 4.98, and we get 9.02. Remember, pOH and pH are unitless. Okay, let's do this next one now. This next one's going to need an extra step. Find the pH if the concentration of OH minus equals this. So let's come over here. we have the concentration of OH minus equals 10 to the negative pOH. We're trying to find pH. pOH equals negative log of the concentration of OH minus. But we don't have an actual formula that directly relates these two. We can't compare OH minus to pH directly, because pH is all about H plus. But you know what we can do? We can use this number to find the pOH, then we can use the pOH to find the pH. So anytime you're asked for something other than like OH minus and you're asked for something to do with H, you're going to have to do two steps there. So let's go ahead and do these. We're going to find pOH first. Here's the formula right here. Notice it looks very similar to this one. The only difference is there's an OH instead of an H. So pOH equals the negative log of this, 2.64 times 10 to the negative 13. And that's going to be our pOH, and we're going to plug that into our calculators. Negative log of 2.64 times 10 to the negative 13. We get 12.6. Okay? And therefore, pH equals 14 minus 12.6. And there we get the 1.4. So, do notice honors folks. I'm going to talk about sig figs again. Academic, you don't need to listen. But honors folks, notice we needed 3 sig figs here because of this. But when we subtract 14, we're looking at the placement of the numbers, and that's going to go to the 10th. So we did actually lose a significant figure here. That's okay. That's okay. It's actually correct. Okay, that will happen sometimes. Okay, so let's do the last one here. pOH equals, we always have to calculate pOH first with OH minus. We can't get directly to pH. The negative log of 3.45 times 10 to the negative 8. Okay, plug that into our lovely calculators. We get negative log of 3.45 times 10 to the negative 8. We get 7.46. Now that's our pOH. We're trying to find the pH. 14 minus 7.46. And we get 6.54. Let's think about if it's an acid, base, or neutral. Our pH here is 1.5. That's very acidic, very acidic. Our pH is 6.54. Yeah, that's acidic, not as much. Now there's one more type of problem that I want to show you how to do. Now this one, I think your note packets have 2 examples here, but I'm just going to do one with you. The reason why I'm just going to do one is I'm actually going to show you this one more than one way. I personally like the first way I'm going to show you, but a lot of times my students forget that this second formula exists. So a lot of times my students like to do it the long way, which is fine. Both ways work. So I'm going to work through this both ways. We're going to see that we get the same answer both times. You can decide exactly how you want to do it when you have to do it on your own. So on this one, we have to find the H3O plus concentration. We're given the OH minus concentration as 4.97 times 10 to the negative 10 molar. Okay, here is the formula that you can use. It is in your reference table. It's there. It says that when you multiply these two, the two concentrations, you're going to get 1.1 times 10 to the negative 14. So we are given the OH minus concentration. We're trying to find the H3O plus concentration. Now you remember H3O plus and H plus in this class are used interchangeably. So that concentration times the OH minus concentration equals this constant. Oh, by the way, I'm using this formula right here. We know this. We're trying to find this. And here's a constant. No matter what, when you multiply those together, you're going to get 1 times 10 to the negative 14. Now, one thing that makes this tricky is you're going to have to divide by a number in scientific notation. And sometimes students get mistakes in their calculators when they do this. So I want everyone to pull out your calculators. Even if you're sitting at home and watching this at home, I want you to pull out your calculator. Pause the video if you need to. Pull out your calculator and we're going to type this in. You can do one of two things. I'm going to show you, remind you how to use the E function. But at the very least, if you don't want to use those E's, you've got to make sure you put parentheses around this number. Because if you don't, and you type this in verbatim, your calculator is going to think that it's two different numbers. It's going to end up multiplying your final answer by 10 to the negative 10th rather than dividing. But let me remind you on how to use the E's. Top doesn't matter so much, but I'll go ahead and walk you through how to do the E's so you can see it twice. We're going to do 1. So type in the number that's not the exponent yet. But instead of saying times 10 to the, we're going to use the E. The E is right above the 7. You look, there's a comma, and you see right above that comma, there's a blue, on my calculator it's blue, and it's capital EE. Hit second and hit that comma button, and now your calculator should say 1E. We're going to go to negative 14, divided by, now your calculator will treat that number like it's one number, which is kind of nice. It's going to solve our order of operations here. Divided by 4.97, E, negative 10. Now, if you're on the test, if you're taking the test and you forget how to use those E's, you can just type the whole thing in, just make sure you put parentheses around this on the bottom. And in that case, I got 2.01 times 10 to the negative 5. I'll rewrite that so you can see it well. Negative 5. Now, it's a concentration, have to have a unit. Our concentrations have to have that capital N. Our pHs need to have, no units needed there. So there's the first way you can do this. Let me show you how you can also do this. The other way you can do this is use this to find pOH. Use your 14 to find the pH, then use your pH to find this. So it has a lot more steps. This one's just one formula. Sometimes students get worried about dividing by those scientific notations. Sometimes students forget to use it. So it's okay, whatever method you want to use, and it's going to end up giving us the same, if not very similar answer, if not the same. So first thing we got to do is find the pOH, because we can't directly go from OH minus to H3O plus unless we use this formula. We've got to get to pOH, then pH, then H plus. So those are two ways you can do it. So pOH equals the negative log of the OH minus concentration, which is 4.97 times 10 to the negative 10th. And when we plug that into our calculators, we get 9.30. 9.30. Okay, now we've got to find our pH. It's going to be 14 minus the pOH, which is 14 minus 9.30. So when we do that, we get 4.70. Now, I'd rather you not retype in the 9.30. It'd be better if you keep using the answer function in your calculator, because we don't want to have to round this many times, and we'll end up with different answers in the end. If we do end up with different answers in the end because of rounding, I don't typically take off points for that. But it does make it more similar, accurate if we're just using that answer function. So that's our pH. So if you look at that, that can tell us that this is an acidic solution. But we're looking for the H3O plus concentration. So the H3O plus concentration equals 10 to the negative 4.70. So now we got to plug that in, 10 to the negative 4.70, and I get, ooh, this is so cool, I love it when this happens, 2.01 times 10 to the negative 5th. We need a unit, molar. So this one on top is definitely shorter, but some students really just feel very comfortable using these 5 formulas. They don't like this one as much. So some students really do prefer to do it this way. I'm okay with either way. As long as you can get to that final answer, you write the units. honors, you're thinking about sig figs, if that's the case, you are good to go. Now there is one more thing I need to show you.